This test method can be used to determine the air content of normal and heavyweight concretes. However, it cannot be used with highly porous aggregates, such as found in lightweight concrete. This test method will determine the amount of both the entrained and entrapped air voids in the concrete. Air entrainment is necessary in concrete that will be exposed to cycles of freezing and thawing and to de-icing chemicals. The microscopic entrained air voids provide a source of internal pressure relief within the concrete to accommodate the pressures that develop as ice crystals form in the pores and capillaries of the concrete. Without the proper air content in the mortar fraction of the concrete, normal concrete that is exposed to cycles of freezing and thawing will scale and or spall, resulting in a durability failure of the concrete. However, care must be taken not to have too much entrained air in the concrete. In concretes designed to produce 3,000 to 5,000 psi compressive strength, as the air content increases, say above 5%, there will be a corresponding reduction in the strength of the concrete. Typically, this strength reduction will be on the order of 3 to 5% for each 1% of air content above the design value. For example, a concrete proportion for 5% air will be approximately 15 to 25% lower in strength if the air content rises to 10%. This test method covers the determination of the air content of freshly mixed concrete. The test determines the air content of freshly mixed concrete exclusive of any air that may exist inside voids within aggregate particles. For this reason, it is applicable to concrete made with relatively dense aggregate particles and requires determination of the aggregate correction factor. As with any hydraulic cement concrete testing, always wear the minimum proper protective equipment required. In this video, we will demonstrate an air content test pressure method using a Type B pressure meter and a strike-off plate. The sample must be obtained in accordance with ASTM C172, sampling of freshly mixed concrete. When testing concrete with a slump less than 1 inch, an internal vibrator must be utilized for consolidation. When testing concrete with a slump greater than 1 inch, but less than 3 inches, rotting or internal vibration is allowed. Concrete with a slump greater than 3 inches must be rotted. This test method is applicable to plastic concrete if the concrete contains coarse aggregate particles that would be retained on a 2-inch sieve, wet sieve a representative sample over a 1 1/2 inch sieve. Dampen the interior of the measure and place it on a flat, level, and firm surface. Remove any standing water from the bottom of the measure. Fill the mold in 3 equal lifts. Rod each lift 25 times uniformly over the cross section with the rounded end of the rod. While rodding the first lift, rod the layer throughout its depth using care not to damage the bottom of the mold. After rodding, tap the outside of the mold 10 to 15 times with a rubber mallet to close any holes left by rodding and to release any large air bubbles. For the second lift, rod the layer throughout its depth and approximately 1 inch into the previous lift. After rodding, tap the outside of the mold 10 to 15 times with a rubber mallet to close any holes left by rodding and to release any large air bubbles. For the third lift, rod the layer throughout its depth and approximately 1 inch into the previous lift. After rodding, tap the outside of the mold 10 to 15 times with a rubber mallet to close any holes left by rodding and to release any large air bubbles. Representative material can be added or removed as needed prior to strike-off. Strike off the top surface of the concrete and finish it smoothly with the flat strike-off plate, leaving the measure level full. Press the strike-off plate on the top surface of the measure to cover 2/3 of the surface. Withdraw the plate with a sawing motion to finish only the area originally covered. Place the plate on top of the measure to cover the original 2/3 of the surface. Advance it with a vertical pressure and a sawing motion to cover the whole surface of the measure. Continue to advance the plate until it slides completely off the measure. Incline the plate and perform several strokes with the edge of the full measure to achieve a smooth and level surface. Thoroughly clean the flanges or rims of the measure and the cover assembly so that when the cover is clamped in place, a pressure-tight seal will be obtained. Assemble the apparatus. Confirm that the main air valve is closed between the air chamber and the measure and open both petcocks. Using a rubber syringe, inject water through one petcock until water emerges from the opposite petcock. Inject water until there are no longer air bubbles present. While continuing to inject water into the petcock, jar the meter gently until all air bubbles are expelled from this same petcock. Close the air bleeder valve on the air chamber and pump air into the air chamber until the gauge hand is on the initial pressure line. Allow a few seconds for the compressed air to cool to normal temperature. Stabilize the gauge hand at the initial pressure line by pumping or bleeding off air as necessary while tapping the gauge lightly by hand. Close both petcocks. Then, open the main air valve between the air chamber and the measure. Tap the sides of the measure smartly with the mallet to relieve local restraints. Lightly tap the pressure gauge by hand to stabilize the gauge hand. Read the percentage of air on the dial of the pressure gauge. Release the main air valve. Calculate the air content by subtracting the aggregate correction factor from the indicated air content. Report the air content to the nearest 0.1%. If the air content is greater than 8%, the reading shall be reported to the nearest 1/2 scale division on the dial.